Hello everybody. This is your first video in our series of videos for Unit 6, which is on sampling distributions. If you remember the dorky little crown that I wore in class. So this unit is all about sampling distributions. This video is just the basics, right? And I'm going to try to make these videos a little bit shorter. I'm breaking this unit up into smaller parts for you, so the videos you have to watch are not like quite as long as some of the other ones you've had to look at in the past, all right? So this video is just on basics of sampling distributions, and then we'll get a little bit more specific. So let's go ahead and jump into it, okay? So just a couple of quick vocab basics that you need to make sure that you know, okay? It's especially important starting in this unit and for this semester that we know the difference between all of these things, because it will impact the formulas we use and the symbols we use and things like that. Okay, so a distribution is just a collection of data. Okay, so it's just a bunch of numbers or information. Okay. And we've talked about a lot of different types of distributions. Right? We've talked about normal distributions in Unit 3. We've talked about population distributions kind of throughout. We've talked about probability distributions in Unit 5. And then this unit is on sampling distributions. Okay. Important distinction here between population and sample. Okay, so just as a reminder for you, a population is the entire group being studied. Okay, then the numerical description of a population is a parameter. Okay, so that's any value that could describe some aspect of a population. So its size or its mean or its standard deviation, okay? But as you probably recall from Unit 1, that it's almost impossible to get information from every member of a population. That's very difficult, which is why we as statisticians work with samples, right? So a sample, in the most basic of terms, is just a part of the population, a small part of the population. Okay, and these are described by statistics. Okay, that's your numerical descriptor. Okay, these can also be a mean, a standard deviation, a size, right? But there is a difference between a sample mean or a sample proportion or a sample size and a population mean, a population proportion, or a population size, right? These values right here, the parameters, these values are our truth. Okay, if you recall, this class is all about a search for the truth. Okay, parameters are very difficult to come by, right? Which is why this class is called statistics and not parameters. If we knew parameters, then we wouldn't need to take samples and do experiments and do all of these other things. Okay, so really quickly, let me change my color here. I'm hoping that you guys will be able to see this purple color. So just as a reference for you, okay, the table here that I'm filling in for you, okay, on the right hand side of your screen corresponds here to what you see on the left side. Okay, these are just the symbols that we use for parameters versus statistics. Okay, so for mean, the true value is represented by that weird looking U with the extra tail. Okay, but the sample value is represented by X bar. Okay, variance is this Greek symbol omega, not omega. Oh my goodness. I'm blanking, but this is a Greek symbol. So this Greek symbol theta, there it is. Oh my gosh, squared. And then for samples, it's represented with an S. Standard deviation is again that Greek symbol, but it's not squared this time, right? And then for samples, it's just an S, okay? For size, for a population, you're dealing with a capital N. For a statistic, for a sample, you're dealing with a lowercase n. For proportion, you're dealing with a lowercase p, that's your parameter. And then your statistic value is something we call p hat. So it has one of those little carets above the p, okay? All right, so like I said, this unit is about sampling distributions, okay? But really quickly, before I jump into that, okay, I just wanna make a quick note for you all, okay, that this unit is gonna be split up into one section is about proportions and one section is about means. Just as a reminder, when you're looking at proportions, a good way to tell is that you're looking at categorical data. If the question is about means, then it's a good chance you're looking at quantitative data. Okay, little AP tip for you. Okay, it's important to indicate when you're talking about these values that you indicate if you're using a statistic or a parameter. Okay, like I said, the parameters are the true values, right? The parameter is the truth, okay, which is often what we are in search of, right? Or we are going to use these statistics in order to estimate what that true value is. Okay, so when you're using a parameter, you should use phrases like true proportion or population value or population mean. Okay. All right, so let's talk about sampling distributions. Okay, so here's your definition of sampling distributions. A sampling distribution is a collection of statistics. Okay, so i.e., lots of sample means, proportions, standard deviations, etc. Okay, from all possible samples of the same size from the same population. Okay, so rather than creating a dot plot, say with the number of spices in your spice cabinet, right? You would pull a small sample and of spices from your spice cabinet. Say, pull a sample of 5 from your spice cabinet, and you would record maybe the proportion of those that were that looked red, for example. Okay, right? The way that we build sampling distributions is rather than having to actually go out and gather all of these samples for the most part, and then repeat that process over and over and over and over again until you build up enough data to create a sampling distribution. Usually what we do is we run simulations and collect a statistic from each sample. Okay, so they're built from running many simulations and collecting a statistic from each sample. Okay, whether that be a mean, a proportion, a standard deviation, a variance. In this unit, and really for most of the rest of the semester, we're mostly going to be focusing on means and proportions. Okay. Okay. One other really important term, or a couple other really important terms to kind of start us off with this idea of inference, okay, is this thing called statistical inference, which you probably don't realize that you've been using all year long. We just didn't really have a name for it yet. Okay, so statistical inference is what we do as statisticians when we use information from a sample to draw conclusions about a larger population. Okay. Go like that. It's a little easier for y'all to see here. Okay, so the thing about statistical inference, since it's being pulled from samples, right, and we have all this natural variability that just exists in the universe, right? So you could pull a sample, one sample that's not representative of your whole population just by random chance, right? So if you only take one sample, your inference may not be accurate, right? It may not be an actual um, or a good representation of the true values, the population values, which remember, that's the whole point of this, right? That's what we're looking for, okay? We can't guarantee that if you take only one sample, that the proportion you get or the mean that you get will be equal to or will be even close to the true value. But we can guarantee, because of our use of randomness, that our sample methods will usually yield the truth if we repeat them many, many, many times. Okay? And so then there's this like big question that we have to contend with, which is how often would your particular sampling method yield the true value, the exact truth, if we repeated it many times? Okay, and that's kind of an overarching question that we're going to attempt to answer throughout this unit and throughout the semester. Okay, and the last little important thing that we need to talk about here is sampling variability, which again, you've kind of been using all year. I just don't think I've given you an explicit definition for it yet. Okay, so sampling variability is the value of a statistic, basically says that the value of a statistic varies in repeated random sampling. Okay, so I wrote it in slightly different terms down here at the bottom, which is that means or proportions will vary depending on the individuals that get selected from a random population. Okay, so that's what I mean when I say if we just take one sample, we don't know if that sample is an accurate representation of the population or of the truth. Okay, but if we use a computer to run a simulation of some kind, right, uh, and collect many, 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 many samples, right, then if we have enough of that data, then we'll be able to get a pretty good idea of what the true values are. Okay, so that's where the last little bit of this video comes in, which is this diagram right here. Okay, so typically, right, when you're taking samples, you start from a population, right, which has a set true value about it, right, a set parameter, which we might know or we might not know, right? So here, right, in the population distribution, the parameter is the truth. Okay, from that population, we pull many different simple random samples, which is what's happening here, right? So each of these distributions in the middle is a distribution of sample data. So this is a sample distribution, okay, which gives an individual statistic for each sample, right? So each of those are statistics. Okay, because they describe some aspect of the sample, which in this case is a proportion, right? It's a sample proportion. It's p hat, has that little hat on it. Okay, if we use a computer to run this type of simulation many, 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 many times, right, we end up with a sampling distribution, okay, where each of these individual little dots, right, so like this little dot right here, is a sample proportion. A sample proportion, or a p hat value. okay? Each of these p hat values is not the truth, right? Because we have a wide range of possible values here. These are approximations of the truth. Oops, let me erase here. I'm going to actually type this because that would take me way too long for me to write. Okay, so each of those p hat values are approximations of the truth that come from samples. Okay, right? And what we're going to get into in the rest of this unit is that the more samples you take, the closer you're going to get to the true value. Okay, if you notice, it looks like most of the sample proportions are ending up at around zero point 0.5, which was the parameter, which is the true value from the population. Okay. All right, you guys, so that is it for this intro video. Next video is going to be pretty short. It's just about describing sampling distributions, and then we're going to get into the actual properties of sampling distributions, and I'll do some practice problems for you. All right, you guys, so that's it, and I'll see you in the next video. Bye, everybody.